Good day, everyone. My name is Mr. Shegun and I'm a mathematics tutor. So today we're looking at a very important topic in mathematics, which is swords. Now, I know that we've heard of, or we've most likely treated this topic before, or some of us have, studied this on our own. But I'm going to give us a better understanding and shed more light and take some practice questions and solve them so we can get a good understanding. Now, what are swords? So I'll start with the definition of what swords are and then go on into questions on how we can simplify swords and also solve some problems. Alright, now swords are basically irrational numbers. They are irrational numbers. Swords are basically irrational numbers. Now I'm going to break this down so we can easily understand this. Now, what are irrational numbers? Irrational numbers are decimal numbers, alright? So say for instance, if you have a decimal like 3.287. Now if this mantissa, alright, the numbers after the decimal point are called mantissa, the number before the decimal point are called integers, right? So if the mantissa continues, alright, meaning if it is endless, if it goes on and on, such number is an irrational number, alright? So irrational numbers cannot be expressed as a fraction. So you can't say, or you can't convert this to a fraction like a over b, alright? So when we say swords are irrational numbers, most likely they are decimal numbers, but their mantissas are endless, alright? They continue going from on and on and on, alright? So examples of swords, you have root 2, you have root 5, you have root 6, you have root 7, you have root 17, and so on and so forth. So each of these numbers are irrational numbers. They are swords. So, and I said one of the characteristics of irrational numbers of swords is that their mantissas are endless. It goes on and on and on. Alright, so now that we've gotten a basic understanding of what swords are, I would like to give us the opposite of what swords are, right? Now we have what we call perfect squares. Now, to get a better understanding of what swords are, let's see what perfect squares are. Right? Now, the direct opposite of swords, is perfect squares. It's perfect squares. Now, why do I say this? Now, the difference between a perfect square and a sword is that whenever a sword basically is an irrational number, right? But perfect squares are rational numbers, they are integers, alright? So you can have something like square root of 64, you can have square root of 25, square root of 16. So these are not swords. The reason for this is because if you should punch this on your calculator or if you find the square root of these numbers, it will give you a rational number, that is an integer, a whole number. So for instance, root 2 is root 64 that is 8, this is 5, this is 4. So you can see that each of these numbers they are integers, right? So that's the difference between perfect squares and swords. So now that we've gotten that, so let's quickly go into some questions and then see some examples. Alright, so we want to quickly look at simplification of swords. So whenever you are dealing with swords, the first thing you would like to take note of, the first thing you would like to learn is how to simplify swords, right? So having the background or the knowledge that swords are irrational numbers, of which I've told us earlier, now we want to see how we can simplify them, right? So let's go ahead and do that. So we have a question here, it says, simplify the following. A, square root pq squared. Alright, so we have about 5 questions here, so let's take the first one. This is square root of pq squared. Square root of pq squared. Now, before I go into this, alright, I want to let us know something. Before I commence this, now there's what we call rules of swords. Alright? Now you need to understand these rules because these rules will help you or will guide you whenever you are simplifying, not just simplifying, whenever you are adding sorts, multiplying sorts, and also dividing sorts. So this rule guides you and make sure you do not make mistakes while you are doing your simplification or your arithmetic operations, right? So let me show us the rules of sort that we use whenever we are simplifying sorts, alright? Now, the first rule you would like to know is, I call it the rule of multiplication, right? If you have square roots of x times y, now square root of x times y is still the same, right, as square root of x times square root of y. So this simply means you can decide to separate them, right? So it still means the same thing. So if you have square root of x times y, I can decide to say square root of x times square root of y. So please, I call this the law of multiplication, right? So this is the first law of, or the first rule rather, of sorts. Now the second one is, if I have square root of x divided by so just as it is applicable to multiplication, it is also applicable to division. So if you have square root of x divided by y, it's still the same as saying square root of x divided by square root of y. Very simple and clear. We have about 4 rules we're going to go through. Alright, the third one is this. Now, because it is applicable to multiplication, applicable to division, but this rule is not applicable to addition. So please let me state this. The third rule here states that if you have square root of x plus y, alright, in a single square root sign, it's not the same, it is not equal to, this symbol simply means not equal to root x plus root y. So it is wrong for me to write something like this, square root of x plus y, and say it is square root of x plus square root of y. Alright, so this is very, very wrong. So that's what that means. So please, it is not applicable to addition. Now let's take the fourth rule. Also, subtraction, it is not applicable, that rule. You can't separate them, alright? Square root of x minus y, leave it at that. Make sure you subtract whatever you have there. Don't try to bring them out, alright? So, it is only applicable for multiplication and division. So, we're going to use this rule. Now that we have this knowledge, it is with this, we're going to use it to solve or simplify, rather, these sorts. So, let's take the first question. It says square root of pq squared. So remember, p here is multiplying q squared. So if I have something like pq squared is still the same as saying p times q squared. Correct? Exactly. So this is square root of p times q squared. So you can see how I brought it out. It's still the same. So if I have square root of p times q squared, now, using the law of multiplication, what happens? I have to separate them, right? Exactly. So you take the first one, square root of p times square root of q squared. You can see it. The reason why I can apply this is because here we have multiplication. Alright? So, now that you've applied that rule, let's go ahead with the simplification now. Now, square root of p. Square root of p, since we don't know the value of p, right? So we are going to leave it as square root of p. Now, p can be p is a variable, alright? What I mean by variable is p can be any number, alright? Since we do not really know what the number is, we are going to leave it as square root of p. It would be wrong for me to say square root of p is p. Please, square root of p is not p. The reason why square root of p is not p is because p is not specific. P is a variable. We don't know the number. P might be 4, p might be 10, p might be 5. So you can't say that square root of p is p. Alright, so that is why we don't do that. So rather, what we do is that we just leave it as square root of p. Now, let's now move to this. Times square root of q squared. Now, q squared is what I call a perfect square. It's what I call a perfect square. Now, why do I call this a perfect square? Beautiful. A perfect square is formed when you multiply a number by itself. It's as simple as that. A perfect square is formed when you multiply a perfect square number is formed when you multiply a number or a figure by itself. Alright? Now looking at this, we have a variable here, which is q. Now if you multiply q by itself, that's q times q, it will give us what? Q squared. Remember what I said about perfect squares. What are perfect squares? They are formed when you multiply the variable or a number by itself. So you can say I'm multiplying q by q. It gives me what? Q squared. So this is an example of a perfect square. So the same thing goes for every other numbers. So if I have, for instance, 4, if I multiply 4 by the same 4, I'm going to get 16. So obviously 16 is a perfect square. If I pick any random number, I say 7, I multiply by that same number 7, I'm going to get what? So this is how you can form perfect squares. It goes on and on. Just pick a number and multiply it by itself, you have a perfect square. So now you understand why I said q squared is a perfect square, because it was multiplied by itself. Now, if q squared is the perfect square, then what is the square root of q squared? It's just like saying 4 times 4 is 16, right? So the square root of 16 obviously is what? Is 4. So since q times q is q squared, the square root of q squared is q. So I'll put down q. So I'm not going to put down the square root symbol again. Alright? So square root of p is square root of p, but square root of q squared is just q. So you're not going to include the square root sign again. Now, once we are done with this, multiply them together. Square root of p times q. Now, whenever you want to do this, square root of p times q is not square root pq. It's wrong. It's not square root pq. Now, the reason for this is because this q doesn't have a square root. So it is wrong for you to say square root p times q is square root pq. Instead, this comes over to this side and becomes the coefficient of this side. So what you will have is q square root of p. Q square root of p. So please, this tells you something. That if you have a number multiplying a surd, let's say root 5. So it would be wrong for me to say this is root 15. 3 times 5. No, this is wrong. So because this is not a surd, alright, what will happen is that this 3 comes to this and becomes the coefficient. So you have 3 root 5. I believe that is very clear. Alright, so please take note of this. So moving on to question B, it says square root of x squared y cubed. X squared y cubed. So remember, square root x squared y cubed is still the same as what? Square root x squared times y cubed. So they are multiplying each other. Okay, so remember the law of multiplication, alright? What do? Separate them. So you see what I did there? So I had to separate it. Okay, now let's start with the first one. So just like we did for square root of q squared. The square root of q squared is q squared rather was q, right? So obviously what will be the square root of x squared? It will be x. Square root of x squared will be x. Now we have square root of y cubed. Square root of what? Y cubed. Now, what is square root of y cubed? What is square root of y cubed? What is square root of y cubed? Now, y cubed, this is what you should ask yourself. Is y cubed a perfect square? Now, we obviously know that x squared is a perfect square, right? So that's why I said this was x. But ask yourself this, is y cubed a perfect square? No, it is not a perfect square. Remember what I said about the definition of perfect square? What are perfect squares? You get perfect squares, or perfect squares are formed when you take a number and multiply it by itself. Now look at this, alright? Or, if you want to put it in a better way, when you take a number and multiply it by itself in even number of times. Even number of times simply means it must be 2, 4, 6, 8. So what I mean is, if you take p for instance, p times p, you're multiplying p twice, right? That's p squared. P times p times p times p. So it must be even. 1, 2, 3, 4. You can see that now, right? This is 2, this is 4. You have p times p times p times p times p times p. How many times am I multiplying here? I'm multiplying 6 times. So whenever you do this, you will always arrive at a perfect square. So that is the definition of what a perfect square is. Now, but looking at y cubed does not fit into this category. Why? Because if I multiply p by 3 times, 3 is not an even number, right? It's an odd number. So this does not qualify as a perfect square. So please, in other words, if the power of a variable is odd, it is not a perfect square. If the power of the variable is even, it is a perfect square. Simply put. So, because I don't have a perfect even number here, so this is not classified as a perfect square. So I'm going to leave it as, what do? We're going to leave it like that. We're going to say this is square root of y cubed. And then multiply them together, I will say x times 2, that's x. So therefore, this is our answer. So that's how you simplify them. So let's take the third one. Now, we have square root of 75. So we've been working with letters and variables. Let's deal with actual numbers. Now, how do we simplify 75? We know that 75 is a surd, right? It's an irrational number. But how do we simplify it? This is it. Whenever you have a number, the first thing you would want to do is to apply the law of multiplication. And what do I mean by that? Make sure you separate them, just like I did here. Alright? Now, how do you do that? You look for two factors of that number. Now, one of the factors must be a perfect square for this to work. Well, let me recap again. Whenever you want to simplify this, look for two factors. One of the factors must be what? A perfect square. Now, looking at this now, for 75, if I were to have two factors that would multiply to give me 75, one of them has to be a perfect square. What factors would you look at? What factors are you looking at? You can think and just brainstorm and check on your Now, because of time, alright, the factors I'm going to pick are 25 and 3. I'm sure you have guessed already. Exactly, you are correct. So, this 25 times 3. Beautiful. Because 25 times 3 also gives me what? Square root of 75. Beautiful. So, please, that's just the first step. You can use any other factors too. There are other factors of 75, alright? But the reason I'm using this is because one of the factors here is a perfect sum, and which is that? 25. So you can decide to use other factors, alright? In fact, you can decide to use 5 times 15. We have 5 times 15. The reason I wouldn't use 5 times 15 is because none of these factors are perfect squares. So I'm sure we are getting the point now. So I can't use this. So that's why. So please take note of that. So let's go. So I'll separate this. 25 times square root of 25. Since 25 is a perfect square, right? Square root of 25 is 5. and then we have root 3. So this is 5 times root 3, that's 5 root 3. So this is my answer. Oh yeah, let's quickly move on to the fourth one. Roots or square root of 45. Square root of 45. Now you do this for me. Look for two factors that will multiply together to give you 45. One of them must be a perfect square. So think about that and let me know the numbers you are looking at. Because of our time, let's go straight down to the point. We have two factors. I'm sure you must have guessed it already. We have 9 and 5. Correct. So we have square root of 9 times 5. Beautiful. Why am I using 9 times 5? Because one of the factors there is a perfect square. And which is that? 9. Correct. So separate it. And then, what do you have? Square root of 9 obviously is what? Is 3. And then 5. Multiply this to, this is 3 roots 5. That's the answer to that. And then for the last question we have square root of 300. The same thing. So, and that's the solution to all the questions. So, very quickly, we'll be moving on to another subtopic, and then so we'll be looking at how to add and subtract SURDS, and then from there we'll progress into something else. So please stick close to the end of this video while we take on the next subtopic, which is addition and subtraction of SURDS. I want to look at addition and subtraction of SURDS. Alright, so how we can add SURDS and how we can also subtract them. So we have a question here. It says, evaluate the following. A, 3 root 2 plus 4 root 2. So we're going to start with the first one, and then the second, and then the third. Alright, so let's go. A. So it says this is 3 root 2 plus 4 root 2. So how do we add SURDS? That is the question. Now this is, let me say this before we go on with this. Now when it comes to addition and subtraction of SURDS, this rule applies to both. Now, when you're adding or you're subtracting SURDS, you would make sure that the SURD, when you have two SURDs, right? It doesn't really matter if the coefficients are different. What matters is the value you have in the value of the SURDs. So if the values of the SURD in the two numbers or in the two rational numbers are the same, you can add them. Now this is what I mean. Look at this. You have 3 root 2 plus 4 root 2. Because I have root 2 here and I also have root 2 here, so this is conformable for addition. It's just like saying you are dealing with algebraic processing, right? If you have 3x plus 4x, what's 3x plus 4x? That's what? 7x, correct. That's still the same procedure for addition. The same thing goes for subtraction also. 3x minus 4x, that will be what? Minus x. So the same principle you apply when it comes to algebraic processing is still the same principle you are going to apply when it comes to addition and subtraction of SURDS. So let's quickly take this. So this simply means I'm going to have 3 plus 4, then I have into brackets what? Root 2. Or I can decide to put it this way. Whichever. So 3 plus 4, that's 7. This is 7 root 2. Alright, let's take the second question. 2 root 125 plus root 45 minus 8. This is minus 8 root 5. Now, how do we add this? Now, one thing also you need to know is simplification of SURDS comes to play whenever you are doing addition and subtraction of SURDS. Now, how do I mean? This is what I mean. Whenever you have a SURD, alright, make sure, or you're adding a SURD, make sure you simplify it to its lowest term before you add. Now, the reason why I did not do any simplification here is because this here is already in its simplest form. So you can no longer break 3 root 2. You can't break it down further. Alright? So that is why you can go ahead and add. But when it comes to questions like this, alright, I wouldn't just go ahead and start adding them. After all, I can't even add them in the first place. Why? Because the numbers here are different. So the first step to addition or subtraction of sort is simplification. Then you can now add. So let's simplify this sorts together. Remember, we've dealt simplification of sorts, right? So let's go. Now I'm going to put down 2, right? Now remember, just like what we said, whenever we are simplifying sorts, what do we say? We look for 2 factors, right? And what did I say? 2 factors. One of the factors must be a what? A perfect square. Correct. Now in 1 to 5, what are the 2 factors of 1 to 5 such that one of it is a perfect square? So that will be take a guess, right? That will be 25 times 5. You guessed correctly, exactly. So this will be 25 times 5 because 25 is a perfect square. Yeah, quickly let's move on to the next one. 45. The factors are 9 times 5, exactly. And then you can't break 5 down, right? So 5 is still 5. Now, so we have over here 2 root 25. Remember the law of multiplication, we can separate them. Is that correct? Exactly. So that's the same thing I'm doing over here. I'm separating them. Then this doesn't need any. Alright? So just separate them. The law of multiplication. And now the next thing we're going to do is I will have 2. Since 25 is a perfect square, square root of 25 is what? 5. Correct. So that will be 2 times. Remember, these 2 are multiplying each other. So this is still the same as 2 times root 25. So since I'm not going to put down root 25 again because I already know what square root of 25 is. The square root of 25 is what? Is 5. Correct. So I'm going to put down 5 and then times root 5. And then write down plus, what's the square root of 9? Square root of 9 is 3 times root 5. And then minus what? 8 root 5. So what I have here is 2 times 5. 2 times 5 gives me 10. 10 root 5. And then I have 3 times root 5. That's 3 root 5. And then I have here what? Minus 8 root 5. So you can see now that the first thing I did was to simplify these sorts, right? So I can go ahead and add them together. So now that I've simplified this, I'm not going to do the addition and subtraction here. So please do not forget, simplification comes first before any other form of operation, whether addition or subtraction when it comes to sorts. Alright? So please make sure you simplify the sort before you add or subtract them. Alright, let's go. So for this, alright, is it possible to add or subtract this? Yes. Why? Because they have equal sorts. You can see that, right? So let's say for instance, if this was 3, it will be impossible for me to add this. It will only be possible for me to add this and this, but not this. Alright, so they must all be equal. So I have 10 plus, just pick the coefficients, 3 minus 8. And then square root of 5. 10 plus 3 is 13. 13 minus 8 will give us 5. So this is 5 root 5. And that's the answer to question B. So question C, lastly, 2 root 18 plus 2 root 54 minus root 108. So the same thing like I said earlier, simplification must come first before you add or you subtract. So let's simplify this first. Now, what are the factors of 18 that? So that will be 9 and 2 because of our time. Then this is 9 and 6. Yes. And then this will be, this should be 36 and 3. 36 times 3. 36 times 3. 36 times 3. Now, you might be wondering, why did I pick something that has maybe, why did I use 36 as? Because 36 is a perfect square. Now, I could have even decided to use 9 times for 108 now. Alright, 9 times, I can try to use 9 times 12, right? Now, why am I not going to use this? Because 9 is a perfect square, is that correct? Yes, but why am I not going to use this? The reason I will not use this is because, please, I want us to listen very carefully. It's because for 12 can also be simplified further. So you don't really want to do something like this because 9, correct, 9 is a perfect square, no doubt. But you see 12, in 12 you have 4 times 3. 4 times 3 will give you 12, right? So this is what I mean. For 12 you have 4 times 3. So this simply means you have a perfect square that is a factor of 12. So you would not want to get something like this. So whenever you are looking for 2 factors, make sure that one of it, just one of it, is a perfect square. If the other one is not a perfect square, but the factor of the other number is a perfect square, please make sure not to use that. I don't know if you understand what I'm saying, but I hope you understand, alright? So please, we can't use 9 times 12, we'll have to use 36 times 3 because the only perfect square here is 36, but 3 is not a perfect square. So please take note of that. So back to what we're discussing. So we have times 3 using the law of multiplication. Just separate them. So square root of 9 is 3. 2 times 3, you have root 2 plus 2. Square root of 9 is 3 also. You have 6, root 6. Square root of 36, that's 6, and then you have root 3. So I have here 6 root 2 plus 6 root 6 minus 6 root 3. Okay, now I want us to watch this closely. Is it possible for me to add all of this? Is it okay for me to say 6 plus 6 minus 6? No, I can't do that. Now, why can't I do that? Remember I told us, whenever you want to add or subtract, make sure the surds are the same. So I can say for this now that this is not conforming for addition or subtraction. Why? Because the numbers or the surds here are different. The reason I did this here was because the surds were the same. Look at that, right? Over here also, 2 and 2. But over here, they are not the same, so you can't add. So you stop at this point. So therefore, my answer is 6 root 2 plus 6 root 6 minus 6 root 3. So that will be all for this video. Although there are still more on surds, we have a lot on surds, we have conjugate surds, we have a rationalization of surds, a lot on the surds, alright? But I hope we've been able to get a basic understanding of what surds is, how to simplify surds, and also how to add and subtract them. So thank you so much for watching. See you in our next class.